Good morning, students. How are you? I hope all of you are doing well. Today, I'm going to teach about decimals and I welcome you all in today's class. So, let's start our class. Decimals. Fractions having 10, 100, 1000 and so on as denominators are called decimal fractions. Example, 1 by 10, 1 by 100, 1 by 1000. Here 1 by 10 is called as tens place, 1 by 100 is called as hundreds place, 1 by 1000 is called as thousands place. The above fractions, that is 1 by 10, 1 by 100, 1 by 1000, they can be represented as decimal numbers also. We keep a point between them. Let's see the example. 1 by 10, it can be written as 0 0.1, 1 by 100 as 0 0.01. So when we read these fractions, 1 by 10, we will read as 0. When it is converted in the decimal form, it will be read as 0 0.1, and 1 by 100, it will be read as 0 0.01. The value of a decimal part does not change even if any number of zeros are added at the end of decimal point. Example, 0 0.4 is equal to 0 0.40 is equal to 0 0.400 and so on, etc. Decimal point is used after the units place. Let's see the example. 3 here in the example is 391.291. So here the decimal point is used after the unit place. That means the number in the unit place here is 1 and the decimal point is used after this unit place, that is 1 after 1. The left side of the decimal point is called the whole number part and the right side of the decimal point is called the decimal part. That means the number at the left side of the decimal, that is 391, it is called as the whole number part, and the number at the right side of the decimal point, it is called the decimal part. And how to read a decimal point? While reading a decimal number, decimal part is read as separate digit. Example, 399.291. Here 391, the whole number part, it will be read together. That means 3 as 399, and the digits in the decimal part, that is 291, it will be read separated as 399.291. Then next, comparisons of decimals. Rule 1. If a decimal number has greater whole number part than another, then it is greater of the two. Let's see an example here. If the let's take an example as 2.91 and 5.72. Let's compare these two decimal numbers. According to rule 1, if a decimal number has greater whole number part, here in the first decimal number, the number in the whole part is 2, and in the second decimal number, the number in the whole part is 5. So when we compare 2 and 5, 5 is greater. So among these two decimal number, 5.72 will be greater than 2.91. Why? Because the number in the whole number part is the number in the whole number part for the second decimal number is greater than the number in the whole part of the first decimal number. Then rule 2, if two decimal number have the same whole number part, that means, for example, for this, if two decimal number have the same whole number part, let's say 3.17 and 3.21. So if two decimal number have the same whole number part, then first one, compare the digits in the tens place. So here in this example, the number in the whole number part are all same. That means they have the same number 3. In this case, what we have to do, we have to compare the digit in the tens place. That is the digit just after the decimal point. So we have to see the digit. For the first number, it is 1, and for the second number, it is 2. So when we compare 1 and 2, 2 is greater. So which decimal number will be greater between these two? The number that has the greater number in the tens place will be the greater. We have studied rule 1 and rule 2 for comparisons of decimals. So let's now let's see the number B of rule 2. If the digits in the tens place are also the same, compare the next digits in hundred places and so on. Habidi karino koina ngasai first rule 1 dana karigumba whole number part to the hana yengadoni karamana chawgi have do karamana chawi have the achauba leba whole number part ta achauba lebuduna chawni haigre. Second gi rule dana kari hagi koina ngasagi whole number part to chamana ragadi koina tens place the ladiba masing do compare to rokani haigo karigumba tens place the ladiba masing dugi achauba masing duna greater or any haire. Duga rule number b dana what it is said ngasagi whole number part sumana raba digit 10 places to lady but digit to sumana ragadi koina mathang karai diangani we have to compare the digit in the hundreds places 100 place to lady but digit to mu compare to rani sigi examples the ding asagi 100 ahambagi masings dana 100 place to lady na 2 akombagi zina 3 ore adu itadi koina compare masing ani je compare to matamda 3 is greater than 2 so the second decimal number that is 5.132 is greater than 5.123. Then next, to convert a decimal number into a fraction. To convert a decimal number into a fraction, first remove the decimal point and write the number as numerator. Place as many zeros after 1 as there are digits in the decimal part and write it as the denominator. So decimal number amabu kamain taw na koina fraction da convert tarokani haba matamda. Let's see an example. Here example is given as 24.15. Examples the 24.15 haina piname ko kamai tawna khoi shigi 24.15 haiba decimal numbers a fraction the onthorakani haiba matamda first we have to remove the decimal point. Piramiba ngasagi decimal number do decimal point je remove tawra matungda koina hariba masing dubu numerator oina irani ko examples the point je lauthokra matungda di koina numerator da kari hani ire 2415 and in the denominator we have to write 1 han irani aduga maning da koina kari hapakani we have to place as many zeros after 1 as there are digits in the decimal part and write it as the denominator hai ko koina 1 si iraba matung da 1 gi matung da 0 hapakadoini adu 0 do kari gi matung in hapakani ngasagi piramiba decimal number dugi decimal part ta lariba digit tugi masing gi matung in koina denominator 0 hapakani ko in the given example here after the decimal point we have two digits. See examples the koina decimal point gi matung the digit ani laire aduna koina ngasai gi denominator da 1 gi matung the 0 ke hapani we have to put two zeros. Then to convert decimal fraction into decimal form, count as many places from right to left in the numerally as their zeros after 1 in the denominator and place the decimal point. Ngasai magiduna fraction decimal number dagi fraction the change toba. Hojikisina fraction dagi kamai na decimal form the change torokani haba matamda ngasai gi akoina numerator da lariba masing duda denominator da lariba gi 1 gi matung da laiba 0 dugi matungina akoina ngasai gi numerator duda points na makadoini ko. Here in this given example numerator the is 250 later 250 je when ibirani then after that what we have to do we have to put the decimal point according to the number of zeros in the denominator the yar ba zero dugi masing karom dagi count oraga from right to left right side dagi som the masing thira kadoni so zero ani na koina sta kai dorani two places masing thira ani ko here 1 2 then after that we have to place the decimal point. Then next, like and unlike decimals. Like decimals. Decimals having the same number of digits after the decimal point are called like decimal. Like decimal means like decimal decimals having the same number of digits after the decimal point. Sigi decimal point jigi matung da lerakpa digits se loina manaragadi hariba decimal dubo koina it is known as the like decimals. Here let's see an example here. 2.57, 0.09, 11.76. Hariba piriba example ahum sida loina decimal point jigi matung da digit ani loina laire. Aduna such type of decimal is known as the like decimals. Then unlike decimals, Decimals having the different number of digits after the decimal point are called unlike decimals. Habdi ngasagi decimal point dugi matungda leriba digits singdo manadragadi masing manadragadi whether one can have 1 digits, 2 digit, 3 digit. Adumaina masing khenaragadi number of digit laibagi masing do khenaragadi aduguma decimal duguna we known as the unlike decimals. Let's see an example. 0.253, 19.01, and last one is 1.9. So sigi example ahum sida aham bagizina decimal point matung da digit ahum laire akom bagizina decimal point matung da digit 2 laire akom bagizina only 1 digit haibdi decimal point matung da laiba digits amta manadre amana 3 leba amana 2 leba amana 1 leba sumaina decimal point matung da lairakpa digits singje khetnaragadi such type of decimal are known as the unlike decimals. We may change unlike decimals into like decimals by putting required number of zeros after the extreme right digit of the decimal part. Masagi ko na sigumba unlike decimals zibu like decimal da change of vi, but how? By putting the required number of zeros after the extreme right digit of the decimal part. Masagi decimal part to gi iroi loiba masing ko khwaidagi loiba masing dugi matungda koina zeros hapaaga like decimal ohenba yaiba. Let's take an example. Here 2.54, then 71.2, 11.257. Have the piramiba masing decimal numbers in amta manadre ko all are unlike decimal. That means the first one have only 2 digits after the decimal point, the second one only 1 digit, and the third decimal number have 3 digits after the decimal point. ꯈ꯭ꯋꯥꯏꯗꯒꯤ ꯏꯆꯥꯎ ꯆꯥꯎꯕꯁꯦ ꯀꯔꯝꯕꯅ ꯑꯣꯏꯔꯦ ꯁꯦ 3 digit ꯑꯣꯏꯔꯤꯁꯤꯅ ꯑꯣꯏꯔꯦꯀꯣ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯉꯁꯥꯏꯒꯤ ꯃꯃꯥꯡꯗ ꯂꯩꯍꯧꯔꯤꯕ digit ꯑꯅꯤꯁꯤꯁꯨ ꯁꯤꯒꯤ 3 digit decimal point ꯃꯇꯨꯡꯗ 3 digit ꯁꯦ ꯌꯧꯅꯕ ꯑꯩꯈꯣꯏꯅ change ꯇꯧꯔꯅꯤ ꯀꯃꯥꯏꯅ change ꯇꯧꯒꯅꯤ it can be changed into a set of like decimal as followsꯉꯁꯥꯏꯅ already sida haigre ko akoina unlike decimal amabu like decimal da change tawrake haragadi akoina darkar roiba masing do karina hapakani haigi zeros so ngasai gi ahamba gi masing jidi only 2 decimal obine ahum wegadamina kaya wale ama wala ban digit ama wala bina here we have put 1 zeros here then in the second decimal number kaidore so it has only 1 digit but we have to make it 3 digits right so we have to put 2 zeros here then in the last one using a side 3 digit to siga chamana semakpena sagi anisha loina semgre ko and how we can change it we can change the unlike decimals into like decimals by putting the required number of zeros after the extreme right digit of the decimal part. Addition and subtraction of decimals. We first change the given decimals into a set of like decimals. Then we write the decimals one below the other, keeping the decimal points in one vertical column. The digits are placed according to their corresponding place values. Let's take an example. Add 1.2, 0.482, 5, 637.2. So in order to add these unlike decimals, first we need to convert the given decimals into a set of like decimals. So after converting into like decimals, we have 1.200, 0.482, 5.000, 637.200. Then after that, we have to put the decimal numbers one below the other, keeping the decimal points at one vertical column and keeping all the digits in their corresponding place values, and then we have to add it. Next, rules to be followed while multiplying. When a decimal number is multiplied by 10, 100, 1000 and so on, then decimal point in the given number moves as many places to the right as the number of zeros in the multiplier. Example, let's say an example. Here in this given example, 2.55, the decimal number 2.55 is multiplying by 10. So how we will get the answer? In the answer, we have to move the decimal number to the right side according to the number of zeros in the multiplier. Have the Nasagi multiplier the riba 0 dugi masing matungina koina kaidarani piramiba given decimal number dugi right side to move to godoini ko. In this example, sigi example sigi kaidare nasai 2.55 into 10. So the only 1 zeros are there. So we have to move the decimal point to the right side one place. Ama khaktang place ama khaktang chatlaga kaidarani koina we have to put the decimal point. Then multiplication of a decimal number by a whole number. Multiply both the numbers In the end, the decimal point is placed in such a way that the number of decimal places in the product is equal to the number of decimal places in the multiplicand. That means decimal number the whole number multiply taropadi. First we need to multiply both the numbers. Piramiba decimal number and the multiply taroni. In the end, the decimal point is placed in such a way. Decimal point it will be placed in such a way that the number of decimal places in the product is equal to the number of decimal places in the multiplicand. Have the multiplicand the decimal after decimal point decimal places to give matungina koina ngasagi masing animal multiply taropadugi result du da kai dorani adugi matungina koina decimal point nam ani ko. So given examples that ngasagi multiplicand la irize decimal point matungda digit ama khatang la ire aduna koina in the product what we have to do, we have to put the decimal point according to the number of digits after the decimal point in the multiplicand. Next, multiplication of decimal number with another decimal number. So decimal number amada decimal number amana multiply taropagi. Step 1, ignore the decimal number. Then step 2, now multiply the number. First step ta akoina masing ani multiply decimal number ani masing multiply taropase ke dorni. Let's see an example here. Say 36.32. Yeah, I have given here 32. So 32.5 into 2.5. Now we are going to multiply these two decimal numbers. So in the first step, what is said in the first step? We have to ignore the decimal number. That means by ignoring the decimal number, we have to write it. That means 325 into 25. Then in step 3, count the total. Then now we have to multiply the number. So 5, 5, 25. 5, 2 are 10. Plus 2, 12. 3, 5 are 15. 1 carry, 16. 2, 5 are 10. 2, 2, 4, 1 carry, 5. 2, 3 are 6. Then let's see. 5, 2, 11, 7, 8. So now we have got the answer as 8125. In step 3, count the total number of decimals in the multiplier and the multiplicand. Now we have to count how many number of digits after the decimal point in both the multiplicand and the multiplier. So in the multiplicand also after decimal point only one places, in the multiplier also only one places. So now we have 2. Then step 4, count the same number of places from right to left in the product and place the decimal point before to that. Koina ka dawning asagi phangiba result to the product to the asagi sita like riba masing ay digit ani like record place the decimal gi matung da ani like matung ina sa count auraga karom side ta right side gi left side ha som side ta count ani ko 1 2. Then after that we have to place the decimal point before to it. Having a size of decimal number amada multiply to the first normal na multiplication to the decimal number say ignore tauraga tariba result to the decimal point se kamaina when a place or can have multiplicand so multiplier so division on the decimal numbers. When a decimal number is divided by 10, 100, 1000 and so on, the decimal point in the given number moves as many places to the left as the number of zeros in the divisor. Let's see an example. Decimal number amabu koina 10, 100, 1000, 10,000 minus divider pamatamda asagi the decimal point in the given number. Given number the remember decimal point though where it will move as many places to the left as the number of zeros in the divisor. Asagi divisor da lairiba zero dugi matungina koina decimal point given number gi decimal point do move taurani ko karom da left side da. So let's take an example 36.8 divided by 10. So 36.8 say 10 divider pomatam da divisor da first we have to look in the divisor that how many zeros are there. Here pyramid example the zero maya aure to na koina asagi decimal number to the how many places we have to move. We have to move 1 places to the left side and now we have got 3.68. Let's take another example 53.2 divided by 1000. So 53.2 is the 1000 divided by divisor se yangani 0 kya lehaba there are 3 zeros 0 hum lere ko adu itadi koina piramiba given decimal number to the 3 places move tawrani karom side ta left side ta. So here If there are not enough places on the left, we keep zeros in these places and place a decimal point. Ngasagi left side to the, if there are not enough places like tragedy, we keep zeros in these places. Zero hapchalani khoina aduga we have to place the decimal point. So in this example, in the divisor there are 3 zeros. So we have to move through 3 places to the left side. So let's see the answer. Here 1, 2. 2 places are there, but there are not enough places on the right side. So in order to have enough places, what we have to do, we have to keep zeros in these places. So here I am putting here 0, then after that we put the decimal point. When a decimal fraction is divided by a whole number, as a divisor crosses a decimal point in the dividend, a decimal is placed in the quotient. Hamdi decimal number amabo koina whole number na divide tarokpa matamdadi kamaina tarani. Let's see an example here. 45.2 is divided by 2. That means the decimal number 45.2 is to be divided by 2. So here 2 2 are 4. Then after that we have to bring down the next number again. 2 2 are 4. Then after subtracting 4 from 5, we got the remainder 1. Here now we have crosses the decimal point. So in the definition it said that as a divisor crosses the decimal point in the dividend, a decimal is placed in the quotient. Ngasagi akoina divisor do kaidawra, divisor do na dividend da decimal point do cross oraga di akoina decimal point do quotient da thamni hagi ko. Now we are crossing the decimal point, so we have put the decimal point here in the quotient and we bring down the next number and we have got 2 6 are 12. Let me stop here for today. In the next class, we will solve some questions related to the explanation that I have done. So, thank you all and have a nice day.